So today we're going to talk about nonlinear inequalities. We've talked about linear inequalities. Those are those straight lines. Remember the shading where we did the graphs and we shaded like a half plane, things like that? We're going to talk right now about firstly quadratic inequalities and then rational inequalities. See what those things are for, see what they look like. So first off, we're going to talk about some quadratic inequalities. Now, do you remember quadratic equations? Remember the quadratic formula? X equals minus 3, all that stuff. They dealt with the x squared, yeah? That's what we're going to be doing, only now in an inequality. So quadratic inequalities look something like this. Is that quadratic?
Yes.
What makes it quadratic?
X squared.
Yeah, it's power 2, right there. That's a that is a quadratic. That's what we mean. Hey, by the way, could you factor that? Well, could you try to factor that? Okay. Could you use quadratic formula on that? Absolutely, that would work all the time. You guys still with me right here?
Yeah.
All right. Now, that's a quadratic expression. An equation would be if I have an equal sign. Right now we're going to deal with that thing. That's what makes it an inequality. So is it quadratic? Yeah. Is it an inequality? Absolutely. We're dealing with quadratic inequalities. I'm going to give you some steps over here. These are kind of your general steps. The first thing you're going to do, you got to make sure this is in what we call standard form, which means we want this everything on one side and 0 on the other side. Why? Well, the only way we know how to work with quadratics is if everything's on one side and 0's on the other side. You with me on that? So we want everything on one side, 0 on the other side. That's called standard form. So first thing, we're going to write this in standard form. And we mean everything on one side and then some inequality and then 0. That inequality, by the way, doesn't have to be that particular one. We could have a less than, greater than equal to, any of those things. So step number 1, write that in standard form. Hey, let's look up at the board here real quick at our example. Folks, is that in standard form?
Yes.
Yeah, everything is on one side, 0's on the other side, and we have that inequality. Now, do you remember, hopefully you do you remember a long time ago when we did the linear inequalities, how we temporarily set that expression equal to 0? Instead of having the inequality, we had the equal sign. Do you remember that? We're going to do the same thing here. This is the only other part in the history of mathematics where you temporarily change an inequality into an equal sign. And it's simply so that we can solve it. So step number 2, you're going to temporarily write as an equation and you're going to solve it. So instead of looking at the inequality, we're going to say, okay, let's make that an equal sign for now. Temporarily, we're going to set that thing as an equal sign. The only reason why we do this is so that we can solve it. Ladies and gentlemen, first thing, what would you try to do with that equation? Now it's an equation. We've done these before. What do you do now? You try to factor. How long would you spend factoring? And then after trying to factor for 10 seconds, if you couldn't do it, what would you do? Okay, factor. Okay, so you're factoring that thing. Hopefully you were able to factor this. How do you factor it? Sweet. If you weren't able to factor it, of course, we could still use quadratic formula to get the same exact answers that we're about to get. Are we done right now? Yes, no, folks. Are you guys?
No.
Okay, so we're going to do the x plus 4 equals 2. I'm sorry, equals 0. And x minus 2 equals 0. We'll subtract 4. We'll add 2. And of course, we're going to get x equals negative 4, x equals positive 2. So far, so good? All right. Now, we've done the first two steps. We've made sure it's a standard form. We've temporarily written it as an equation, and we solved it. However, this is where a lot of people are going to leave it. Look, if you leave your equation right here, it's like this doesn't even exist. Because this is what you would be doing from here down, right? This would be like stuff we've done in chapter 11.1, 2, and 3. That's it. This would be it right here. This has to mean something. Now here's what this means. This means that you're going to have some intervals that work, and you're going to have some intervals that don't work. If you remember about the like linear inequalities and the absolute value inequalities, remember the interval notation we had with the brackets and the parentheses? We're going to have that stuff again. Here's how you find out what intervals there are. Up to this point, this should be very, very easy for you. This is way old stuff at this point. This is actually chapter 7 stuff. You know how to factor already. Here is the new stuff. Are you ready for the new stuff? Hopefully you're ready. Are you ready? Yeah. Ready? Okay. Here's the new stuff. From here on out, what you're going to do is you're going to write a number line. Do you remember what a number line is? What's that? Number line? You're going to write those solutions on a number line. I'm going to move up here so you can see this really clearly. Write these things on a number line. You know what? It doesn't have to be the scale or anything. You don't have to have a 0 on it. You just got to make sure that these are in the correct order. That's all you got to do. Make sure they're in the correct order. So on a number line, which one's going to come first, ladies and gentlemen? Good. And then those are the numbers you need right there. Now, watch carefully. These numbers are going to reappear. They're going to appear again in your intervals. I guarantee you're going to have a -4 and a 2 in just about 3 minutes, okay? You just got to figure out, how many intervals do you see, by the way? You only see 2 intervals? Tell me something. If you had a loaf of bread and you sliced it twice, how many pieces would you get?
3.
You only get 2 pieces?
3.
You have a loaf of bread. You cut it once, how many pieces you get?
2.
You cut it twice, how many pieces you get?
3.
So how many intervals do you have here?
3.
1, 2, 3. You with me on this? Now check it out. Some of these intervals are going to be true. They're going to work. Some of these intervals are not going to be true. They're not going to work. It's up to you to figure out which ones work and which ones don't. So far, standard form, easy. Write as an equation for just a little bit, easy. This is just so you can solve it, easy. It's factoring your quadratic formula. You've already done that. Take these things, put them on a number line, and then you're going to test a point for each interval. Are you with me on this? You're going to test a point for each interval. So step 4, here's the big step. This is the most important step for you. I can almost guarantee you that everyone's going to be able to get down to here because it's just factoring. So step number 4, for each interval, you're going to test a point. Not -4 and 2, because those are actually on the interval separations right there. But something between here. What's between here? 0 would be a great point to check, right? That's easy. What point is over here? Yeah, maybe 3. How about over here? Negative, yeah, not -3, right? That's in this one, but -5 or something. You're going to test those points in, do I want to test it in my equation here or my inequality? The equation, that was temporary. We go back to the inequality. So for each interval, you're going to test a point in the original inequality. The original inequality. I ran out of room, so step 5 I'm going to write right here. Now, what's going to happen is some of the intervals will be true, some of the intervals will be false. The true intervals, you're just going to write those true intervals in interval notation because those are your solution sets. So step number 5, last thing, write the true intervals in interval notation. That's your solution. Okay, shall we give it a try? Firstly, can you give me a hand raise if you're okay on the standard form, the temporary equation, temporary, this is not what you check later. The solving it down to your points using the factoring or quadratic formula, and then writing them on a number line, raise your hand, feel okay that far. Good deal, okay. Now comes for the most important part, the checking. By the way, again, what point are you going to check in this interval?
0.
Check 0 if you can. Oh my gosh, that's so nice. Write the point you're checking up top, okay? Now, how about this one? What point are you going to check over here?
3.
You can check whatever you want, 3, 4, 5. You just can't check 2. You can't check 2 because that won't tell you anything. How about over here? Are you seeing where I'm getting those points, ladies and gentlemen? It's just one single point in that interval. You test those in the original inequality. I'm going to do this piece by piece so you can see it. You're going to show the work on your own. But I'd say, okay, here's my test for -5, here's my test for 0, and here's my test for 3. For -5, what this says is you're going to go back to your original inequality, simply plug in -5. See what that gives you. So -5 squared plus 5 times -2, I'm sorry, -5. Oh, I screwed that up, didn't I? Yeah. Have my numbers reversed. 2 times -5 minus 8, and you're checking to see whether this is greater than 0. Do you remember doing something like this before? Remember checking that and see if it was true or false? It's basically the same idea. You're checking a point. So here we're going to get, how much is this going to give me, ladies and gentlemen? Come on, everybody should be playing along here. And then plus or minus 10? Minus 8. Bigger than 0. So this says that, if I do that math correctly, 25 minus 10 minus 8 should give you 7. Hey, here's what we did. We checked one point, this -5, in my original inequality. It said that 7, ultimately 7 is bigger than 0. Is that a true statement or a false statement?
True statement.
Definitely a true statement, right? 7 is bigger than 0. So that's true. What you're going to do, you're going to put a true right there in that box. That goes true. Now, you can trust me on this, or you can do it for yourself about 100,000 times to see that what I'm about to say is going to be true. But your intervals will alternate. For quadratics, they will alternate. And here's the reason why. Do you remember talking about quadratics, how they're parabolas? And what we're really doing is finding where you cross the x-axis? Do you remember that? So this crosses at 2 points, -4 and 2. It crosses there. So one interval is going to be true, positive, then false, negative, and then true. Does that make sense? Or it's going to be true, negative, false, positive. True. Either way, these things will alternate. It will go true, false, true, or false, true, false. Does that make sense? Now, before you go, all right, cool, I'm going to check one point. That's awesome. What if you get this point wrong? Right? What if you mistakenly do this incorrectly and you get that's a false? Well, then you do false, true, false, right? So here's my point to you. Check all 3 just to make sure you have it. The reason why I told you it should go true, false, true, or false, true, false is so you can check your work. Does that make sense? With quadratics, you're not going to get true, true, false. You're not going to get false, false, true. Right? You're going to get true, false, true, or false, true, false. Are you with me on that? But be sure to check all 3 points. Please do that. It's worth your time. So the next one, 0. 0 is the nicest point to check. We can plug this into our original inequality. We'll get 0 squared plus 2 times 0 minus 8. And what this says is negative 8 is greater than 0. Ladies and gentlemen, negative 8 is greater than 0. True or false? What do you think? That's absolutely false. So in this box, you're going to put a false. Lastly, the 3 will have a 3 squared plus 2 times 3 minus 8 is greater than 0. Should this one come out true or false? What do you think?
True.
It should come out true. Let's see if it does. This is 9. That's 6 minus 8. This gives us how much? 7. 7 greater. Is that true or false? You're going to also see this a lot. It's kind of cool. 7? 7. You see that? 1 unit away this way, 1 unit away that way. That's because parabolas are symmetrical. All right. If you pick the same amount of units to the right and left of these two numbers, you should get the exact same value out. So this is also true. Another reason why, of course, we're going to get a true, false, true, or false, true, false, right? I mean, they're symmetrical. That's true. Okay, I need an honest show of hands. How many people feel okay getting that far? Good deal. Hey, how many of our intervals are true?
2.
So those are the intervals that we're going to write down. Is this interval true? Now here's the interpretation. This is kind of the important part for you. This tells you what numbers are going to work in this original inequality. It says that if you plug in any number to the left of negative 4, that's like negative 5, negative 6, negative 100, negative a billion, or any number greater than 2, 3, 4, 5, 1,000, 5,042, those are all going to work here. Are these numbers going to work here?
No.
No. There's only ones that don't work. So lots and lots of numbers work. Here's how you represent that. Hopefully you remember. We need to write our true intervals in interval notation. So can you look at this interval right here? Where does this interval start? Negative infinity. Sure, because this goes on forever, right? Okay. Now be careful. Where's the interval end?
Negative 5.
That's why we're going to be careful. I got 2 different answers there.
Negative 4 doesn't work.
Okay, let's see.
Plug it in, doesn't work. And you get a 0.
Would negative...
Unless it was equal to 4.1.
Okay. Would negative 4.0000000001 work?
Yes.
Would negative 4 work?
No.
No, why? Well, there's no equal sign right there. But here's my point. You do not stop at this point. That's just the point that you checked. Are you with me on that? You are going to stop at this point. You reuse these 2 points. Are you following me here, folks?
Yes.
You're going to reuse those 2 points. Negative infinity up to negative 4, sure.
Parentheses.
Why parentheses?
Not including the 4.
Oh, you remember that stuff? That's awesome. This is all coming back to us. No equal sign means, well, you had to have parentheses for those infinities. You always had that. That's a parentheses. Now, you're going to list out every other interval that works. Are there more intervals that work here? Okay, so every time you have a new interval, here's what you got to put. Remember that symbol? That's a union that says this one or maybe this one. Okay? Where's the next interval start that works, please?
2.
Parentheses or bracket? Because we don't have the equal sign. Goes to infinity. That is my solution. How many people feel pretty good about this? Now, these can go very, very quick. I'm going to have you do one on your own. Let's all try this.
They don't want you to plug it in how you
Yeah, it doesn't work. That's why you use
On your own.
parentheses.
Okay, go for it.
You're neat.
So we're going to temporarily set it equal to 0. We're going to make sure it's in standard form. We're going to factor if you can. If you can't factor, well, you're going to use quadratic. Honestly, the hardest part about this, the most important part, is checking the points. That's really what it's all about. Everyone's familiar with factor. We learned that really well. You know what a number line is. It's honestly just checking the points. So let's go ahead and let's see if we can make this through. Of course, we're going to temporarily set it equal to 0. Folks, the only reason why we do that is so that we can actually solve it for the crossovers for the x-axis. So we can actually solve it for those interval breaks. So here you temporarily set it equal, and it is factorable. I'm thinking you're probably going to get a 4 and a 3 out of that thing. Did you get a 4 and a 3 out of that thing? So x probably should be minus 4 and x plus 3. Yes, no? Yes, no?
Yeah.
So x minus 4 equals 0, x plus 3 equals 0. We get x equals positive 4 and x equals negative 3. I need a show of hands seeing if you made it that far. Good. Not a problem. We're just factoring. We just have those numbers. What's the next step after you find those numbers? What are you going to do? Yeah, you got to do that. The reason is because you're going to check for the intervals that work. How many intervals are you going to get with the quadratic?
3.
The only time you wouldn't get 3 is if you have a double root. We talked about that a while back. That's the only time you wouldn't. So negative 3 has to go on the left and positive 4 has to go on the right. Hopefully your number line looks like that. And you're going to check a few points here. The points you're going to check, and write those in purple, you're probably going to check 0 since that's a nice number to check. You'll probably check negative 4 and you'll probably check 5. Did you guys check those points as well?
Yes.
Are we checking them in the equation right here or the original inequality? So I'm going to write out negative 4, 0, and 5. I'm going to check those in my original inequality. So negative 4 squared, oh, be careful on this one, minus what? Should it be minus 4 or minus negative 4? Minus negative 4. Be careful on that. Minus 12, and we're checking to see if that's greater than 0. What this comes down to, if we do the math in our head here, we get positive 16 plus 4, that's 20. Minus 12, you should get 8. Did you guys get 8 out of that? Give me a head nod if you did. Yeah, okay, good. So this says, is 8 bigger than 0? Is 8 bigger than 0?
Yes.
So true. That means in this interval right here, we get a big true. Hey, what should this one be then? This one. True? What should this one be? Now you're going to make sure that it is. You're going to double check your work. And that's what the next two parts are for, okay? It's making sure that you got this one correct. Don't just leave it as 1. Check all 3 of those, just to make sure. The 0 is, of course, the easiest one. With 0, we'd have 0 squared minus 0 minus 12. That basically says, is negative 12 bigger than 0? Is negative 12 bigger than 0?
No.
Ah, definitely not. That's a false. So we're going to have a false right there. And this one for sure is going to be true. We've checked 2 points now. We're just going to triple check this with the 5. We'll get 5 squared minus 5 minus 12 greater than 0. That's also 8. 8 is definitely bigger than 0, so that's a true statement. And we verify true, false, true. They're alternating because it's a quadratic. It will alternate, and you get 2 intervals again that do work. All you got to do now, write those intervals out in interval notation, and then you're done with the problem. Where's my first interval start, ladies and gentlemen? And where's it end? Does it end at negative 3 or negative 4?
Negative 3.
Okay. Am I going to use brackets or parentheses here, folks? Sure. Then I'm going to have a union because I have another interval that works. What's the next interval that works? Wait, what's the next interval? 4 or 5? These points you're not using again. Okay, these ones you just checked. These ones, the ones that I have in black here, those are the ones that are going to come back at you. Starts at 4, ends at infinity. That's our answer. Ladies and gentlemen, would you raise your hand if you feel okay with that? If you got that answer? Did you get the answer? Is this easier or harder than you thought it was going to be?
Easier.
Not too bad, right? All it really involves, if you really think about it, it involves factoring and checking points. That's it. You already know how to do everything here. You know how to factor. You know what number lines are. You know how to do interval notation. It's simply plugging those points. Now let's try this with something, I want you to notice that you can still do that one. Something we've seen before but not often. First step, we check to see if this is in standard form. Is this in standard form? Some of you are going, no, not so much. Some of you are going, yeah, sure. What standard form means is that everything's on one side and zero's on the other side. That's what standard form means, whether or not you have a constant. So is this in standard form?
Yes.
Yeah, it is. Yeah, it just doesn't have a plus or minus a number, but that's okay. The next step would be, what's the next step? It's on the board. What's the next step you're going to do? So next step, we're going to say, okay, it's in standard form already. We're going to temporarily set that thing equal to 0, and that's going to allow me to solve this for those interval breaks. Do you follow? Now, don't forget that when we have a problem like this, we can in fact solve it. What would you try to do first again? You factor it. Can you factor that? That's what I mean. Don't forget that you can. Sure, it's not a diamond problem. It's not even 3 terms. It's 2 terms. But what do you check for when you have factoring? The first thing you should check for, which we all forget about, the very first thing, greatest common factor. Do you have something that's common to both those terms? Factor it out. What is it? Factor out an x. Don't forget you can do that. That's why I gave you this problem. You can factor out an x, and if you do, watch carefully, please. What do you get inside?
X minus 6.
Not x squared again, but x minus 6. Are you still with me? Now keep in mind, you still have a zero product property. You have something times something equals 0. You've got to set both of these. Look at the board. X equals 0 and x minus 6 equals 0. It's just like this. It's just like this right here, only you don't have another something being added or subtracted. You follow? So are you still going to get 2 solutions? Absolutely. It's just one of them's easier. One of them's already x equals 0. No problem. The other one's going to be x equals 6. Still so far so good?
Yep.
So this one's even a little bit easier than this one over here. You have a 0. Nice. We set up our number line. Of course, we're going to go from 0 to 6. Oh, but there's a problem. How many intervals do we get?
3.
Definitely 3 still. Can you check 0? No. Why?
Because it's on.
Yeah, it wouldn't tell you anything about these 2 intervals if you checked 0. It'd say, oh yeah, well 0 in this case is going to work because you have it less than or equal to 0. It's going to work, but it doesn't tell you whether this interval works or whether this interval works. So sometimes if you have that 0, you need to pick some different points. What point are you going to pick over here, do you think?
1.
Over here?
-1.
And here?
1.
Anything you want. I'd probably pick 1. I'd probably pick 1 because it's easier for me. And then over here, what are you going to pick?
7.
Yeah, 7. Why don't you try those points for me, see if they work, okay? Oh my goodness, okay, so I plugged in each of these numbers into my original inequality. Hopefully you did this. This one says positive 1 plus 6. That's going to give you 7. Did you get 7?
Yep.
Checking the points is the most important part of this. It really is. It's being careful on those signs and checking your points. I know it's basic pre-algebra. And this is what you learn in integers in chapter 2 of pre-algebra. You learn how to do this stuff, okay? But it's important. You're going to get positive 7 less than or equal to 0. Is that true or false?
False.
Definitely a false statement. That means the first interval where I checked -1, so I checked -1, that's in this interval, it was false. That's definitely not true. So that's false, so I put a false for that interval. Just still following me? Okay, next interval, we're going to plug in 1. 1 says 1 squared, that's 1, minus 6, that's -5, is less than or equal to 0. Is -5 less than or equal to 0?
Yes.
Absolutely, it's less than 0. That makes it true. So I checked 1, it was true. I'm going to put true for that whole interval. You only need to check 1 point, not a whole bunch of them, just 1 point. Next I'll check 7. What should 7 be? Should it be false or true?
False.
It should be false. Why? Because look at false, true. What should that one be? It should be false. It better be. If you got a true, you knew you messed one of these up. Something happened there. It has to alternate for quadratics. So we're going to get 49 minus 42. That's going to give you 7 again. Notice still we have that relationship. They're the same exact number. If you pick 1 unit away in each case, it's symmetrical. It's going to give you that relationship. That's definitely false. We get a false for the interval. Raise your hand if you made it that far and got those same statements. Good. That's the most important part. If you can get that, you got this down. Next thing, we're going to write the intervals that work. Oh, hey, how many intervals work?
1.
1, 2, 3, 20? I don't know. How many?
1.
How many of you marked as true?
1.
1. Then 1 works. So you only have 1 interval. Where does that interval start?
0.
Where does that interval end? Am I going to use brackets or parentheses?
Brackets.
Oh, good. Why?
Because it's less than or equal to.
You look back up there. The interval notation has to come back for you. That says equal to. Equal to meant you have some brackets. Raise your hand if you're okay with that one. Good. Try that one on your own. I'll give you 2 minutes to do that. So it's still quadratic because we still have that x squared. That means you still need it in standard form. All standard form means for you is you're getting everything to one side and 0 on the other side. So you're checking for that. If it wasn't in standard form, you'd be adding or subtracting to move parts over, to make sure you have 0 on one side. This is, of course, in standard form. That's great. You temporarily set it equal to 0. What that's allowing you to do is to find those breaks for those intervals. That's it. After that, you put those numbers that you just found on the number line, and you check however many intervals you have by checking 1 point in the original inequality, and then write out those true intervals in interval notation. That's the whole idea. Hey, what factors out of x squared minus 8x? What'd you do there? That's even easier than a diamond problem, right? Because we just have that single x. So don't forget that you can do that. You get x minus 8. So that means you got 2 points here. You got x equals 0. You got x minus 8 equals 0. Don't forget about that x. And you got x equals 8 and x equals 0. So on our number line, 0 comes first, 8 comes second. We're going to have 3 intervals to check. Of course, we can't check 0, but you can check -1, 1, and 9. Those would probably be the numbers that you check too, yeah? Those are the easiest ones to check in this case. If you check -1, you get -1 squared minus 8 times -1 less than 0. That all gives you 9. True or false?
False.
Definitely a false statement. 9 is not less than 0. Hey, what should that be?
True.
What should that be?
False.
It should alternate. Now, if it doesn't, listen, if it doesn't, that means you did something wrong. You made a mistake on checking your points. So these do need to alternate for you for quadratics. So up here we're going to go, okay, well, let's see. We're going to check 1. 1 squared minus 8 times 1, less than 0. That's going to give you -7. And that's a true statement. Next one, if we check 9, again, you're going to get 9 squared minus 8 times 9, less than 0. That's going to give you 9. So basically, you're triple checking your work here. That's what this does. But trust me, it's good for you to triple check your work. Because a lot of us have problems with just plugging those numbers in, especially when you have those negatives flying around. It's hard, right? So we want to make sure that we're triple checking your work. It has to go false, true, false, or true, false, true for quadratics. It's got to do that. How many people feel okay with this? Got that far? Good. How many intervals work?
1.
One interval. That's going to go from 0 to 8. Don't ignore this part. You have to do interval notation here. 0 to 8. Why parentheses?
Because you have 8 on the side.
Very good. We look back at our original inequality. We check whether that has the equals or not. If it does, brackets. If it doesn't, parentheses. Then you're done. Let's try one more type of example here before we move on into some rational inequalities. You're probably thinking, Leonard, come on. We're having so much fun here. This is easy. Why are you going to throw something like that up there? Well, naturally, this isn't a quadratic. It's not a quadratic anymore. So we're out of the realm of quadratics. Why is this not a quadratic?
There's 3.
Well, imagine for a second. Yeah, there's 3 solutions. That's great. You're going to have 3. Imagine for a second if you distributed it. Do you see how the largest power is going to be a power 3? You get x to the 3rd power there. That's a cubic. So we're now in cubics. However, I haven't taught you how to factor cubics, so they're all going to look like this. And this is a nice thing. You might not realize this is a nice thing for you, but I want you to think about it. Firstly, is everything to one side and 0 on the other side?
Mm-hmm.
So technically, we'll call that standard form. It's not really standard form because it's not distributed, but trust me, listen, do not distribute this. Please don't. Watch what happens if you don't distribute this. Just write this with that equal sign we were just talking about. Just write that with the equal sign. Temporarily write it as an equal sign. Hey, check it out. Look at the word. Doesn't that look a whole lot like that? So basically, the work's been done for you. Is that not awesome? Booyah! I don't have to factor, I don't have to do anything. Hey, look at something times something times something equals 0. Zero product property still works. So what you do is go, oh, okay, well, if something times something equals 0, I know that the first expression has to equal 0, and the second expression has to equal 0, and the third expression has to equal 0. That's got to be the case. So just like we did before, you're going to set each of those parts equal 0, only here you have one extra part. You just have 3 parts there. So x is 2, x is -1, x is -5. Give me a little head nod if you're still okay with that.
Mm-hmm.
Hey, can you still put those on a number line?
Mm-hmm.
-5, good. Then? And? How many intervals do we have here?
4.
Yeah, if you cut a loaf of bread in 3 slices, you get 4 pieces, right? That's what you just done. 1, 2, 3 slices, you get 1, 2, 3, 4 pieces. You get 1 more piece of bread for however many slices you make. You with me? Okay, so here, how many points are we going to have to check? 4 points. Hopefully you're to the point where you know what points we're going to check up here. You're going to check -6. And you're probably going to check -2. Here you're going to check 0, and here you're going to check 3. You with me? Now, this doesn't always have to happen this way, but generally you will still alternate. Generally. You'll go true, false, or false, true. There are rare occasions with some of this stuff where you can go true, false, true. or false, true, true, false, or true, true, false, 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 true, true. You can do that when you get into like calculus level stuff, when you're doing this. It's called the sign analysis test on occasion when you're dealing with this. So please stick with it. It should alternate, but it doesn't have to all the time. Stick with it and check every single interval. Are you with me on that? Go ahead and check those now for me, okay? You know, I'll show you how to do the first one. I'll have you do the rest of them. I want you to see a certain way. If you're checking these, don't distribute it all. All you got to do is make sure that you're for -6. You're plugging it into each one. So -6 minus 2, -6 plus 1, -6 plus 5, and you're checking to see if that's less than or equal to 0. Essentially, I want you to see this. What it comes down to is simply multiplying signs, because you're multiplying something, right? This is -8 times -5 times -1. You with me on that? Hey, is our answer going to be positive or negative here? Negative. Now, it really doesn't matter what it is. You know the answer is going to be negative. You with me? Any negative is going to be less than 0. So we know that this is going to be a true statement right here. We know that for a fact. Now, you can work it out. You're going to get -40. Is -40 less than or equal to 0?
Yes.
Absolutely. So you get a true statement out of that. Yes, no?
Yes.
Do you see where those numbers came from?
How you like the -8? Is -6 plus -2?
Yeah. Yeah, -8, -5, -1. We multiply those things because we are multiplying. You're going to get -40. That, of course, is less than 0. That makes a true statement for the interval. Check the remaining 3 of them for me, okay? Yeah, fraction time. You know it.
Just ruined my whole Monday.
Thanks.
There goes your Monday. Okay, now come back up here. Let's see what happens with these remaining points. Hopefully you were able to check these. If we plug in -2, hopefully you have this on your paper. You got -4 times -1 times 3. Did you all make it that far? Hey, what's a negative times a positive? It's a positive, right? Negative times a positive. That's 2 negatives. That's going to create a positive for you. You're going to get positive 12 is less than or equal to 0. Is that true or false? I need more participation in that. 12, is 12 less than 0?
No.
No, definitely not. We just checked -2. It was definitely a false statement. Now you're going to check 0. I'm going to kind of do these on just in our heads here. If we check 0, you're going to get -2 times +1 times +5. Are you with me on that? -2 times positive times, is that a positive or a negative? Getting negative. Do you see how the signs are what is important for this problem? Do you see that? Because already it's comparing to 0 over here. So you're just checking whether it's positive or negative, basically. This is going to be -10 less than or equal to 0. Is that true or false for this one? And lastly, we'd have 3. If you check 3, I'll do it up here, you'll get 1 times 4 times 8. You see where the 1 times 4 times 8 is coming from, folks? You're going to get 32. Is positive 32. Is positive 32 less than or equal to 0?
No.
It's false. So what it comes down to is checking points. That's all this is about. Now, can you write the intervals in interval notation? How many intervals worked?
2.
So write those intervals out, and we're done. So our intervals over here are, where's the first interval start, ladies and gentlemen?
Negative infinity.
Where's the first interval stop?
Negative 5.
Bracket.
Wait, bracket where?
On the right.
On the 5. How about the infinity?
Parentheses.
You always use parentheses for infinities because you don't know what infinity is, so you can't ever get there. And then what should I have next?
Union.
U, so I need that little union thing. And then where's the next interval start?
Negative 1.
So bracket, yes, absolutely, I heard that. Where's it end?
2 bracket.
Anything else?
New.
No.
Negative infinity to negative 5, not negative 6, negative 5. Negative 1 to negative 2, you're done. By show of hands, how many people feel okay with this one? Yes? You guys over here? Okay. Now, the last thing we got to talk about is rational inequalities. Now, I know these things don't look the best. They don't look the best, but I'm going to prove to you that it's actually not that bad. Here's what you're going to do. What you're going to do. You're going to set both the numerator and denominator equal to 0. Set both the numerator and denominator equal to 0. What that means up here is we're going to get x minus 3 equals 0. We're going to get x plus 5 equals 0. Do you notice how I'm just setting the x minus the top, just set the top equal to 0, set the bottom equal to 0. You with me? Can you solve those? Yeah, absolutely. This is going to give you a 3. This is going to give you a negative 5. And guess what we do now?
Number 9.
Yeah, we have exactly the same situation that we have over here. So is it harder to deal with these fractions? No, it's not harder. They're done for you already. You're going to set this top part, 0. Bottom part, 0. Put it on a number line. Of course, you're going to have negative 5 and you're going to have 3. You're still going to check some points. You're going to probably check negative 6, 0, and 4. But just be careful because you have fractions now. You with me on that? You got fractions, so be careful on checking your signs. I'll do all these with you. With negative 6, you'd have negative 6 minus 3 over negative 6 plus 5. Negative 6 minus 3 over negative 6 plus 5, that's negative 9 over negative 1. Are you following me here, folks? How much is negative 9 over negative 1?
9. Positive.
Wait, positive or negative?
Positive 9.
That's where you got to be careful. You have to follow your signs down. Make sure you know a negative over negative is a positive. That gives you 9. Is 9 less than or equal to 0?
No.
No, that's false. How about 0? So 0 minus 3 over 0 plus 5. Notice here we're going to get negative 3 over 5. Negative 3 over 5. Is that a positive or a negative?
Negative.
So negative 3/5, is that less than or equal to 0?
Yes.
Sure, it's a fraction, but you really don't care what the value of the fraction is. You just care if it's positive or negative because you're comparing it to 0. So in this case, we're going to go, yeah, that's true. Last one, if we check 4. If we check 4, you're going to get, I'll do it right here. Check out 4. You're going to get 1/9. You see how we're getting 1/9? I want you to also notice relationship. This is 9. This is 1/9. Both positive though. Why? Because you have a negative over negative or a positive over positive. This is going to be less than or equal to, is 1/9 less than or equal to 0?
No.
No, 1/9 is a positive number. It's little, but it's a positive number. That means this is false. How many intervals do you have that work? You have negative 5 to 3. Of course, we'll be using brackets here. And that's your solution. There's one more I'm going to show you, but I'm not going to do it with you.
Need to be like more fractions.
Yeah, but it's actually not that bad. It's just one little piece of information you gotta see because it's just slightly different. And here it is. That one. A lot of people make a mistake and they just do one value here. They do the value of 2. Do you see the value of 2 coming up on the denominator there? Unfortunately, that's not going to work for this problem because what don't you have on this side? So here's what you do. You do set it equal. You do set it equal. This is still going to give you, I'm sorry, this is still going to, yeah, you do the denominator. This is still going to give you that value of 2. So this 2 comes from this denominator, but there's one more thing you have to do. You have to also solve that equation, which means you're going to multiply both sides by x minus 2. So you get 3 equals 2x minus 2. Notice I've just moved that off by multiplying it, and you solve that one. Once you solve that, that will give you another solution to put on your number line. So here you get 3 equals 2x minus 4. You add 4, 7 equals 2x, or x equals 7 over 2. That still goes on a number line. Those would be the two things you put on your number line, and then check your intervals. How much is 7 over 2? How much?
1.5.
Yeah, about 3. It's 3. Not about. It's exactly 3.5. So not only do you set the denominator equals 0, you also solve that equation using what you know about those rational expressions, rational equations, and that will give you another point. How many people feel okay with all this stuff? These are rare for you. How many people feel okay with this one? Okay. Good. Okay.